All right, folks. Hello. We are going to do the last section in chapter 6 and the last section for our semester, 6-8, where we're going to deal with principal values of inverse trig functions. What we're going to discuss here in the chapter in the book, it does discuss both and demonstrate both the graphs of the inverse trig functions, and then it talks about the principal values of the inverse trig functions. We are just going to look at the principal values. All right, so not wasting any time, let's get over to our notebook and get to this. All right, so when we talk about the inverse trig functions, what we're going to deal with is primarily arc sine, which you also know as, well, I'll say arc sine theta. You also know this as sine inverse theta. We will deal with arc cosine theta or cosine inverse theta, and arc tan theta, or as you know it also as tan, I just messed that up a little bit. Let me draw that better. Sorry. Tan inverse theta. Now, you may notice that I did something a little bit different here. I used capital letters in the beginning of this. Now, you may say, well, Mr. Guntz, you always use capital letters. Look up above. Well, that's true. But in this, when you see written in our text anywhere else, if you see the arc sine, arc cosine, arc tan, or this version of them, sine inverse, cosine inverse, tangent inverse, written with a capital as their first value, what they're doing is restricting the domain. All right. This notation here restricts the domain of these functions, and there's a reason for that. And I want to point out why we have to restrict the domain in these functions. All right, let's look at an example. If I gave you just the normal, let's see, let me do it in a normal way. If I gave you tan inverse of 1, the angle whose tangent is 1. We know in the past when we were asked to find this, it would say find all values for theta, or to solve for this. So tan inverse 1 equals theta, we'll say. Well, when we did this, we had to say, well, theta could be, we know tangent is 1 here. It's also 1 here. And then it keeps happening repeatedly forever, right? So how would we say that? Well, we would say pi over 4 plus pi k, where k is any integer, right? That was our approach to this. That way we covered all the solutions for this. Now, the thing is, if I punched in tan inverse 1 in my calculator, what happens? All right, it gives you a single value. It can't tell you this. It gives you a single value. And that value it gives you is what we call the principal values of these functions. And they're denoted with these capital letters to start. All right, now what that means is, as I said, we have to restrict the domain. So let's look at each one of these and how we restrict the domain. If we're looking at arc, it almost looked like an A. All right, if we're looking at, it's not much better, arc sine of theta, or again, sine inverse theta, we've got to think, how would I narrow it down to one set of values? Well, let's think about what happens with sine. All right, as we go around the unit circle, we get these y values for all of these that are all the positive signs. And then what happens? We get the same ones in reverse here, and then we get negative values, and we get more negative values. Well, they want to have one uninterrupted domain. So if I do this, and I look at these values, from this point around to this point, this would give me all the negative and all the positive possible values of y, or the sign in the unit circle, would it not? So what domain is this? Well, when we do the graph of this thing, if we graph it out this way, well, I don't want to do that. Let's get rid of that last slide. If we graph it, that would be this part, right, where it's going up to 1, and it would be this part where it's going down. This would be negative pi over 2, and this would be pi over 2, right? In between here and here, we get all the values. So the domain of this is all thetas are going to be between negative pi over 2 and pi over 2. All right, that'll give us all our values for arc sine. So now let's go on and look at arc cosine theta or cosine inverse theta. Let's investigate in the same way. If we look at the unit circle, this one's a little bit nicer because now if I go from here and start, remember, it's all these values, the x values that relate to this as I go around. So these are all the positive x values. Then over here, I get all the negative x values. So from here to here, we get everything that cosine could be. And that shows up again in the graph, because if you think about what cosine does this, where it covers everything from 1 down to -1. And again, I should have probably labeled that on here too, from 1 to -1. But it covers everything from 1 to -1 in one nice interval where this is pi over 2 and this is pi. So from 0 to pi, we get everything. So theta here is restricted to those values between 0 and pi. Finally, we have our arctan, and arctan theta or tan inverse theta. Again, when we see those caps, we got to think, all right, what am I going to use here? And again, I go back to my unit circle. If we think of tangent, tangent is y over x. So I get, as I go around, I get all the positive values, combinations of positive over positive, sine over cosine here. When I go here, I get what kind of values? Well, here I get negative values, but they don't go in a nice seamless way, right? Because they're going to start now sine over cosine back where this was. If we think of what the interval looks like, if we think of tangent, it does this, but then it breaks and does this, right? So it's nicer or easier to get an unbroken interval by doing this instead, going from negative pi over 2 to pi over 2. Again, doing this because we don't get any place that it's undefined in that entire interval. So again, here we're going to use the same thing we did with sine, where everything is between negative pi over 2 and pi over 2. You'll get all values that are possible for tangent. All right. So those are our principal values. And what happens is when we see these, we're going to interpret it as those values that are in between here only, so we get a single answer. And that's where I'm going to try to spend most of my time here is let's do some examples. So if they say find each value, that's all the instruction they're going to give you. They're going to say find each value. And when we find each value here, they're going to give you something like this. They'll say, for example, arctan negative √3 over 3. All right. So the angle whose tangent is negative √3 over 3. Well, think about what that means. If we're dealing with arctan, it's got to be in this. It's negative. It's going to be in this area, isn't it? It's going to be down here in the fourth quadrant because negative pi over 2 to pi over 2, principal value. This is really 1 over negative 1 over √3. Yes, that's what this is in its simplest form. So when we do opposite over adjacent, right? That's what this is, sine over cosine. So opposite over adjacent, this is our reference angle. Opposite is -1, this is √3, right? This would be our 2. So this reference angle is pi over 6. Agreed? So that's going to be a negative pi over 6. So in this case, we would say theta equals negative pi over 6. All right. Again, using our knowledge of the unit circle, we can go backwards on this. All right. Is that visible as a negative? I don't think so. Let me rewrite it. There we go. Negative pi over 6. All right. Let's do another one. A little bit harder. This only works. This is only for these inverse trig functions, guys. Don't confuse it with our other ones. Sine pi over 2. So this, now we have parentheses to deal with. So what do we do with parentheses? We always go to the inside first. So I'm going to just interpret this first. Sine of pi over 2. We know pi over 2 is up here. with the value of 0, 1. The sine is the y value, so we get 1 in here. So this would be equal to cosine inverse, again, principal value cosine inverse of 1. So what is the cosine of this angle? Because it's really saying sine of pi over 2, what's the cosine of that angle? Right? Cosine of the angle, or the angle whose cosine is 1. The angle whose cosine is 1 in this interval, remember we're using this interval, would be this one here. And what value is that? That is, well, where is cosine equal to 1? That's the, I'm sorry, the y value, the x value equal to 1 would happen here, wouldn't it? Where we're at 1, 0. So the angle whose cosine is 1 in this interval from here to here would be right here at 0. So this theta, in this case, is 0. All right, let's keep going. Let's do some more. All right. Let's do another example. Find each value. Arctan, whoops, arctan, I'm writing our cosine. Arctan of 1. The angle whose tangent is 1. Well, we kind of already did this one, didn't we? Tangent is 1 when sine and cosine are the same. That happens here, right? Remember, we're doing arctan as a principal value, so we are only looking from here to here. And so it would be 1 here at an angle of pi over 4. So this would be theta equals pi over 4. Let's keep going. Do another one. Let's do sine inverse of root 3 over 2. All right. Again, if I'm thinking of sine, sine is going to be from here to here only, right? So I'm going from negative pi over 2 to pi over 2. So if I have sine of theta is the angle whose sine is root 3 over 2, and it's positive, it's got to be here. And that means the side opposite is root 3. The hypotenuse is 2. That makes this 1. That's a pi over 3 angle, is it not? So theta is pi over 3. Another example. Let's do sine inverse, again, principal value sine inverse of negative 1/2. All right, so again, where is this going to happen? For sine, it's going to happen between here and here. So negative has to be down here where the opposite side is negative 1. This is 2. That's going to be a negative pi over 6, right? Because we're going in this direction. So a negative pi over 6, because this would have to be the root 3. So theta equals negative pi over 6. Let's keep going. Still just a couple more, just to give you some experience with these guys. Again, you can slow it down and stop and try these on your own before I give you the answer. I think would be a good idea. Let's do cosine inverse sine pi over 3 plus, let's say, no, let's not do the plus on this one. Let's just do this. We have that. All right, so again, as an example, got to start here. Sine of pi over 3. Pi over 3 is here where we have root 3, we have 2, and 1, right? This is 60-degree angle. That's what pi over 3 is. So the opposite side is the root 3. So cosine, well, let's do this. So we do cosine inverse. The angle whose cosine is, well, sine of pi over 3 is going to be root 3 over 2, right? Opposite side is root 3, 2 is there. So we have this. The angle whose cosine is root 3 over 2. So now cosine goes from here to here. This is a positive, so it's going to be here. And the cosine would make this root 3, this 2, and this 1. So now we've got this is theta equal to pi over 6, right? Because this would be pi over 6 as that angle. All right, one last one, and then I'll let you go. Get started. We're going to have tangent of sine inverse 1 minus cosine inverse. These are both principal values on the inside, 1/2. We have this. So we got to start on the inside. This is going to be equal to tangent of the angle whose sine is 1. Well, sine is the y value, and we have to be between here and here. So where is sine positive? Here to here, and it's 1 up here. So that is at pi over 2. Minus cosine inverse 1/2. Again, this is cosine of a positive 1/2. So cosine goes from here to here. Positive would be here to here. So 1/2, the angle whose cosine is 1/2 would have, whoops, I missed again, adjacent side of 1 and hypotenuse of 2. So that's going to be the pi over 3, right? 60 degrees. So that's minus pi over 3. And that would give us tangent of, well, what is 1/2 minus 1/3? Well, that's 3/6 minus 2/6, right? If I change these, I got to get a common denominator. If I do pi over 2 minus pi over 3, I got to get a common denominator of 6. And so that would mean 3 pi over 6 minus 2 pi over 6, which would give me 1 pi over 6, right? So I get pi over 6 here. So what is the tangent of pi over 6? Well, pi over 6 is this, where I've got, I drew that way too small. Tangent pi over 6 is going to be where I have root 3, 1, and 2, right? That's our positive pi over 6. I'm sorry. It's pi over 6, not pi over 3. These are reversed. Tangent pi over 6 is going to be, this is 1, this is root 3. And so our tangent is going to be 1 over root 3, which equals root 3 over 3. And there's our solution. So that's it, guys. We're going to be doing a bunch of these. And we'll go over tomorrow any questions you have with this, but we are going to be working on these principal values for the day. Have a wonderful day, and I will see you, or we will see you tomorrow.